Now this second question is find the sum of the series up to n terms. So this series S is summation r varies from 1 to n r plus 1, r plus 2, r plus 3. Now one way of solving this question is by taking this product and then we'll have r to the power 4 r cube, which is very lengthy way of solving this question. So what we'll do is we'll write its rth term as r plus 1, r plus 2 and r plus 3. Now we'll try and use method of difference in this. So the term before this one, it will be r minus 1 and term after r plus 3 will be r plus 4 and the difference is 5. So what we'll do is we'll multiply and divide everything with 5. So we can write 1 by 5 and this is r plus 1, r plus 2, r plus 3 into 5. Now we want to write this as 1 by 5 and this is r plus 1, r plus 2, r plus 3 and we'll write this as r plus 4 minus r minus 1 and we'll split it in two parts. We can write 1 by 4 and this is r plus 1, r plus 2, r plus 3, r plus 4 and minus and this is r minus 1, r plus 1, r plus 2, r plus 3. So that's our rth term. Now we can write this first term as 1 by 5 and this is 1 into 2 into 3 into 4 into 5 minus and this is 0. We can write its second term as 1 by 5 and this is 2 into 3 into 4 into 5 into 6 minus and this is 1 into 2 into 3 into 4 into 5. Third term is 1 by 5 and this is 3, 4, 5, 6, 7 minus and this is 2, 3, 4, 5 and 6 and its nth term is 1 by 5 n plus 1, n plus 2, n plus 3, n plus 4 minus n minus 1 n plus 1 n plus 2 n plus 3. Now Sn is sum of these first n terms. So we'll add them. We can add this Sn as t1 plus t2 plus t3 up to tn. Now here these terms they'll cancel. Now here we have this left. So here what remains is this expression. So it'll get cancelled. So it'll be this 1 by 5 into n plus 1, n plus 2, n plus 3 into n plus 4. And that is the answer to this question. And since Sn is proportional to n, S infinite will be infinite. So as n approaches infinite, this sum is going to diverge. Now here the question is we need to find sum of these four series. Now this first one is we are given this series which is 1 into 4 into 7, 1 upon 4 into 7 into 10, 1 upon 7 into 10 into 13. We need to find its sum up to nth term and then up to infinity. Now first we will find nth term for this series. Now this is 1, 4, 7. It's an AP. So its nth term will be a plus n minus 1 and common difference is 3. So there will be 3n minus 2. So it will be this 1 upon 3n minus 2, 3n plus 1 and 3n plus 4. Now basically this question is method of difference. Now difference between 1 and 7 is 6, 4 and 10 is 6, 7 and 13 is 6 and 3n minus 2 and 3n plus 4 is 6. So what we'll do is we'll multiply and divide everything with 6. So we can write S as 1 by 6 and this is 6 upon 147 and this is 6 upon 4710 up to 6 upon 3n minus 2, 3n plus 1, 3n plus 4. Now this is 1 by 6. Now we'll write this 6 as 7 minus 1. So it will be this 7 minus 1, and this is 147. Here we'll write this as 10 minus 4. This is 4 into 7 into 10. Here it is 13 minus 7. This is 7 into 10 into 13. And here it is 3n plus 4 minus 3n minus 2. So it will be 3n plus 4 minus 3n minus 2 upon 3n minus 2, 3n plus 1, 3n plus 4. And what we'll do is we'll split these terms. So you can write this is 1 by 6. Now here 7 will cancel. So it is 1 4 minus 4 7. Now here 10 will cancel. It will be 4 into 7. And here 4 will cancel. 7 into 10. Here 13 will cancel. So this is 7 into 10 minus 10 into 13. And we'll continue. And here this 3n plus 4 will cancel. So it will be this 3n minus 2. 3n plus 1 minus, and here 3n minus 2 will cancel, so it will be 3n plus 1 and 3n plus 4. Now if we look at these terms, these successive terms, they'll cancel. Now here we have this first one, then what remains is this last term. So this sum, it will be 1 by 6 into 1 by 4 minus 1 upon 3n plus 1 into 3n plus 4. And that is the sum up to n terms. Now, if we find sum up to infinite, we simply need to take this limit n tends to infinite, Sn. Now, if we take this limit n tends to infinite, this entire expression will be simply 0. So, sum of this limit up to infinity is 1 by 24. So, that is the answer to this first part. And then we have this fourth one, which is this series Sn. So, this is 1 by 4. 1 into 3, and this is 4 into 6. This is 1 into 3 into 5, and this is 4 into 6 into 8, and goes up to n terms. Now for nth term we'll have 1, 3, 5. So it is an AP. So this nth term will be a plus n minus 1 into d. So there will be 2n minus 1, and here this is 4, 6, 8. Which again is an AP. So this is a plus n minus 1 into d, which is 2n plus 2. 4, 6, 8, and this is 1, 3, 5. What seems to be missing is 2. So what we'll do is we will multiply and divide everything with 2. So we can write this Sn as 2 into, and this is 2 into 4, and this is 1 into 3, and this is 2 into 4 into 6. This is 1 into 3 into 5, and this is 2 into 4 into 6 into 8, and this is 1 into 3 into 5 up to 2n minus 1, and here it will be 2 into 4 into 6 up to 2n plus 2. Now if we write its general term will be rth term, and will be this 2 into, and then 1, 3, 5 up to 2r minus 1, and in the denominator will be 2 into 4 into 6 up to 2r plus 2. Now because we have to use method of difference, somehow we have to express it as sum a minus b. So we have to introduce a minus b into this. So what we'll do is we'll write this as 1 here, and we can write this 2, and this is 1 into 3 into 5 up to 2r minus 1, and we can write this as 2r plus 2 minus 2r plus 1 whole divided by 2 into 4 into 6 up to 2r, and this is 2r plus 2. Now what we'll do is we'll split it in two parts. Now we can write this as tr, and this is 2. Now for this first part, 2r plus 2 will cancel, so we get this as 1 into 3 into 5 up to 2r minus 1 upon 2 into 4 into 6 up to 2r, and then minus, here it is 1 into 3 into 5 and this is 2r plus 1 upon 2 into 4 into 6 up to 2r plus 2. So that's your TR. Now if we write T1 will be 2, and here it is 1 by 2 minus, and this is 1 into 3 and 2 into 4, because if you put r as 1, this is 2 and this is 4, and here it will go up to 3. Now if we put t as 2, so it will be this 2. Now this is 1 3, and this is from 2 to 4 minus, and this is 1 3 5 2 4 6, and it will continue like this, and this nth term will be 2, and this is 1 3 5 2n minus 1 upon 2 4 6 2n minus, and this is 1 3 5 2n plus 1 upon 2 4 6 2n plus 2. Now Sn is sum of all these n terms. So if we add them, we'll get Sn. Now here these successive terms, they'll cancel, and since we have this term here, what will remain is this last term, so it'll cancel. So it'll be this 2 into 1 by 2 minus 1 into 3 into 5 up to 2n plus 1 upon 2 into 4 into 6 up to 2n plus 2. And if we find its sum up to infinity, it will be this limit n tends infinite Sn. Now it will be this 2 into 1 by 2 minus. Now here number of terms is n, and here number of terms is n plus 1. So here in the denominator, power of n will be greater, so it will be simply 0. So answer to this series will be 1. And that is the answer to this question. Now here the question is, find the sum of the sequence, and it is 1 upon 1 plus 1 square plus 1 to the power 4, 2 upon 1 plus 2 square plus 2 to the power 4 plus 3 upon 1 plus 3 square plus 3 to the power 4 up to n terms. Now what we are going to do is we are going to write its general term, its rth term. Now for the first term we have 1, for the second term we have 2. So for this rth term we'll have this r, and it will be 1 plus r square plus r to the power 4. Now what we'll do is we'll add r square and we'll subtract r square. We can write this as r upon, and this is a plus b whole square. So it will be 1 plus r square whole square minus r square, which is a plus b into a minus b. So it will be r upon 1 minus r plus r square into 1 plus r plus r square. Now what we'll do is we'll split this term using partial fraction, and we'll introduce a minus sign. So we can write this as TR, and this is 1 by 2, and here will be 1 upon 1 minus r plus r square minus 1 upon 1 plus r square. Now here this 1 plus r square will cancel, and 2 and 2 will cancel, so we'll get the same term. Now our first term will be 1 by 2, and if we put r as 1, it will be 1 upon 1 minus, and if we put r as 1, it will be 1 by 3. Now the second term will be 1 by 2, and here it is 5 minus 2, 1 by 3 minus, and this is 1 by 7. Now this third term will be 1 by 2, and this is 10 minus 3, 7, and here will be 9 and 4, 13. And we continue up to nth term, which is 1 by 2, 1 upon 1 minus n plus n square minus 1 upon 1 plus n square. Now if we add all these terms, we'll get sum of first n terms. So Sn is basically sum of t1 plus t2 up to tn. Now if we add them, these successive terms, they'll cancel, and what we're left with is this first term and last term. So this Sn will be 1 by 2, and then 1 minus 1 upon n square plus n plus 1 or simply n square plus n upon 2 into n square plus n plus 1. And that is the answer to this question. Now in this question we need to find sum of the series up to n terms, and the series given is 1 upon x plus 1 plus 2x upon x plus 1 x plus 2, and this is 3x square upon x plus 1 x plus 2 x plus 3, and continue up to n terms, and the nth term will be n x to the power n minus 1 upon x plus 1 x plus 2 up to x plus n. Now what we'll do is, for this second term we'll add x square and subtract x square. Here we'll add x cube and subtract x cube, and here we'll add x to the power n and subtract x to the power n. So we can write 1 upon x plus 1, and here if we take x common, it will be x plus 2 minus x square upon x plus 1 x plus 2. Here it will be x square x plus 3 minus x cube upon x plus 1 x plus 2 x plus 3, and continue up to x plus n x to the power n minus 1 minus x to the power n upon x plus 1 x plus 2 up to x plus n. Now what we'll do is we'll split each term in two parts. So we can write 1 upon x plus 1, and here x plus 2 will cancel, it will be x upon x plus 1 and minus x square upon x plus 1 x plus 2. Here x plus 3 will cancel, so it will be x square upon x plus 1 x plus 2, and then all other terms, and here x plus n will cancel, so there will be x to the power n minus 1 x plus 1 up to x plus n minus 1 minus x to the power n upon x plus 1 up to x plus n. Now here all these terms, they'll cancel, so what we're left is with these terms and this term. Now 1 plus x upon 1 plus x is 1, so this s will be simply 1 minus x to the power n upon x plus 1 x plus 2 up to x plus n. So that is the sum up to n terms. Now the second question is, we are given this sum a1 upon 1 plus a1 plus a2 upon 1 plus a1 into 1 plus a2 plus a3 upon 1 plus a1 1 plus a2 1 plus a3, and it goes all the way up to an upon 1 plus a1 into 1 plus a2 up to 1 plus an. Now in this also we need to introduce a negative sign, so what we'll do is we'll add 1 and subtract 1. So we'll add 1 and subtract 1 in each of the terms except this first one, and then we'll split each term in two parts. So we can write this sum as a upon 1 plus a1. Now here a2 plus 1 will cancel, so it'll be 1 upon 1 plus a1, and then minus it'll be 1 upon 1 plus a1 into 1 plus a2. In the same way, a3 plus 1 will cancel, so it'll be 1 upon 1 plus a1 1 plus a2, and then minus 1 upon 1 plus a1 1 plus a2 and 1 plus a3, and will continue, and in the end we'll have minus 1 upon 1 plus a1 1 plus a2 up to 1 plus an. Now all these successive terms, they'll cancel, so what we'll get is these first two terms and this last term. Now a plus 1 upon 1 plus a1, this is a1, so it is 1, so this sum will be 1 minus 1 upon 1 plus a1 into 1 plus a2 up to 1 plus an, and that is the answer to this question. Now let us take another question, and here the question is, we need to find sum of first 10 terms of this series. Now what we'll do is, rather than finding sum of first 10 terms, we'll find sum of first n terms. Now we can have this series as 7 upon 2 square into 5 square plus 13 upon 5 square into 8 square plus 19 upon 8 square into 11 square up to n terms. Now we can write this series S as, now 7 is 2 plus 5, so it will be 2 plus 5 upon 2 square into 5 square. 13 is 5 plus 8, so it will be 5 plus 8 upon 5 square, 8 square. This is 8 plus 11 upon 8 square into 11 square up to n terms. Now, if we look at these first terms in the denominator, 2, 5, 8, it is an AP. So we'll find nth term of this AP or rth term. So it will be a plus r minus 1 into common difference, which is 3. So there will be 3r minus 1. So we can write its general term TR as 3r minus 1 whole square. Now this next term is 3 more than the first term. So there will be 3r minus 1 plus 3. So there will be 3r plus 2 whole square. And the numerator, it is simply the addition of these two terms. So it is 3r minus 1 plus 3r plus 2. Now since we have to solve this question, we need to use method of difference and we have to introduce a minus sign. So what we'll do is, we'll multiply and divide it with 3r plus 2 minus 3r minus 1, and which essentially is 3. So we'll multiply and divide it with 3. Now this is a plus b into a minus b. So we can write 1 by 3. And this is 3r plus 2 whole square minus 3r minus 1 whole square upon 3r minus 1 whole square into 3r plus 2 whole square. Now we'll split this. We can write this as TR equals 1 by 3. Here 3r plus 2 square will cancel, so we'll get 1 upon 3r minus 1 square minus, and here 3r minus 1 will cancel, we'll get 1 upon 3r plus 2 whole square. Now we'll write its first term T1, it will be 1 by 3, and if we put r as 1, we'll get this as 1 upon 2 square minus, and it will be 1 upon 5 square. For second term, we'll put r as 2, so there will be T2 equals 1 by 3. And it is 1 upon 5 square minus 1 upon 8 square. Third term will be 1 by 3. 1 upon 8 square minus 1 upon 11 square. And we'll go on. And its nth term will be Tn equals 1 by 3. 1 upon 3n minus 1 whole square minus 3n plus 2 whole square. Now we add them. Now Sn is sum of these n terms. So if we add all these terms, we'll get Sn. Now here 5 square will cancel, 8 square will cancel, 11 square will cancel. Now here we have 1 upon 2 square. So what remains is 1 upon 3n plus 2 square. So it will be 1 by 3, 1 upon 2 square minus 1 upon 3n plus 2 square. And that is solve this series up to n terms. Now in this question, what they have asked for is sum of n terms. So we'll put n as 10. So it will be 1 by 3. And this is 1 by 4 minus, and this is 1 by 30 plus 2, 32 square, which is 1024. Now this is 1 by 3. And denominator will be 1024. And here will be 256 minus 1, 255. If we divide it with 3, there will be 85 upon 1024. So answer to this question is 85 upon 1024, which is your option B. Here the question is, if this limit of summation is 1 by k, we need to find the value of k. Now we can solve this question for infinite, but it's better to solve it for n. So what we'll do is, first we'll find sum of n terms, which is this summation. R varies from 1 to n, r plus 2 upon 2 to the power r plus 1, and this is r into r plus 1. Now its general term, r term is r plus 2 upon 2 to the power r plus 1, and this is r into r plus 1. Now what we'll do is, we'll introduce a minus sign using partial fraction. So we have to split r plus 2 upon r plus 1 in two parts, and this is a upon r plus b upon r plus 1. Now in order to find the value of a, we'll put r as 0 and we'll hide this. So it'll be 2 upon 1. So value of a is 2. And for b, we'll put r as minus 1. We'll hide this. So it'll be 1 upon minus 1. So value of b is minus 1. So we can write this rth term as 1 upon 2 to the power r plus 1. And this is 2 upon r minus 1 upon r plus 1. So this rth term, it will be 1 upon r into 2 to the power r minus 1 upon r plus 1 into 2 to the power of r plus 1. So that's your general term. Now we'll put r as 1. We'll get t1 and there'll be simply 1 into 2 and minus, and here it will be 2 into 2 square. Second term will be 2 into 2 square minus 3 into 2 cube, and we'll continue up to this nth term, which is 1 by n 2 to the power n minus 1 upon n plus 1 2 to the power of n plus 1. Now if we add them all up, we'll get Sn. Now these successive terms, they'll cancel. So sum of n terms of this series, it will be simply 1 by 2 minus 1 upon n plus 1 2 to the power of n plus 1. Now we need to find this limit n tends to infinite. So this limit n tends to infinite Sn, it will be 1 by 2 minus, and here it is infinity, and 2 to the power infinite is also infinite. So it will be infinity into infinity, which is simply 0. So value of this limit is 1 by 2, which is given as 1 by k. So from here, value of k is simply 2. So answer to this question is value of k is 2. In this video, we'll be proving two very important formulas in trigonometry, and which is sum of the series of sine and cosine when angles are in AP. Now the first formula is sine A plus sine A plus D plus sine A plus 2D up to sine A plus n minus 1D. It is sine n d by 2 upon sine d by 2 into sine A plus n minus 1 d by 2. And in the case of cos A plus cos A plus D plus cos A plus 2D up to cos A plus n minus 1D. It is sine n d by 2 upon sine d by 2 into cos A plus n minus 1d by 2. So between the two formulas, if the series is sine, here we'll have sine, and if the series is in cos, then here we'll have cos. Everything else is just same. Now we'll start proving the formula. We'll prove the formula by two methods, and the first method is using trigonometry. We'll start with this first series, which is sine A plus sine A plus D plus sine A plus 2D, and it goes all the way up to sine A plus n minus 1D. Now what we'll do is we'll multiply and divide everything with 2 sine d by 2. So we can write this as 1 upon 2 sine d by 2, and it'll be 2 sine A into sine d by 2, 2 sine A plus D into sine d by 2, 2 sine A plus 2D into sine d by 2, and it goes on up to 2 sine A plus n minus 1 into D into sine d by 2. Now we know that 2 sine A sine B is cos A minus B minus cos A plus B. So we'll use this formula for each of the term in the expression. Now we can write this as 1 upon 2 sine d by 2. Now cos A minus B. Cos A minus B in this case will be cos A minus d by 2, and minus cos a plus d by 2. Now for the second one, it will be cos a plus d by 2 minus cos a plus 3d by 2. Next one will be cos a plus 3d by 2 minus cos a plus 5d by 2, and in the end we'll have cos a plus n minus 3 by 2d and minus cos a plus n minus 1 by 2d. Now as you can figure out, this is nothing but method of difference. Here cos a plus d by 2, cos a plus d by 2 will cancel. A plus 3d by 2, a plus 3d by 2 will cancel. So all these successive terms, they'll cancel. And in the end, we'll get this as 1 upon 2 sine d by 2, and it'll be cos a minus d by 2 minus cos a plus n minus 1 by 2d. Now here we'll use the formula for cos c minus cos d. Cos c minus cos d is 2 sine c plus d by 2 into sine d minus c by 2. So we can write this as 1 upon 2 sine d by 2, and it'll be 2 sine c plus d by 2. Now we'll add them, we'll get 2a plus n minus 1d whole divided by 2 into sine, now d minus c by 2. Here a minus 1 by 2d will cancel. So we'll get this as sine n d by 2. Now we'll cancel this 2 with 2. We can write this result as sine n d by 2 into sine a plus n minus 1 d by 2 upon sine d by 2, which is the formula that we need to prove. If angles are in AP, then sine A plus sine A plus D plus sine A plus 2D up to sine A plus n minus 1D, which is sum of n terms, it is given by sine n d by 2 upon sine d by 2 into sine A plus n minus 1D by 2. Now in the same way, we'll prove this second formula. So we'll start with cos A plus cos A plus D, and this series will go all the way up to cos A plus n minus 1D. Now again, we'll multiply and divide with 2 sine d by 2. So we can write this as 2 cos A into sine d by 2 plus 2 cos A plus D sine d by 2, and it'll go all the way up to 2 cos A plus n minus 1D into sine d by 2 whole into 1 upon 2 sine d by 2. Now 2 cos A sine B, it is sine A plus B minus sine A minus B. So we'll use the formula. Now we can write this as 1 upon 2 sine d by 2, and this is sine A plus B, which is sine A plus d by 2, and minus sine A minus d by 2. Second one will be sine A plus 3d by 2 minus sine A plus d by 2, and this series will continue, and finally we'll get sine A plus n minus 1 by 2d minus sine A plus n minus 3 by 2d. Now this again is method of difference. Now here sine A plus d by 2 will cancel. So all these successive terms, they'll cancel. In the end, we'll get 1 upon 2 sine d by 2 into sine a plus n minus 1 by 2d minus sine a minus d by 2. Now here we'll use the formula for sine c minus sine d, which is 2 sine c minus d by 2 into cos c plus d by 2. So we'll use the formula. We'll get this as 1 upon 2 sine d by 2, and here it will be 2 sine now a minus b. So here a minus d by 2 will cancel. So we'll get this as nd by 2 into cos now c plus d by 2. So we'll get this as a plus n minus 1d whole divided by 2. Here 2 and 2 will cancel. So we'll get this as sine n d by 2 upon sine d by 2 into cos a plus n minus 1 d by 2, which is same as the result that we need. Now here the question is, we need to find the sum of infinite terms of the series cot inverse 1 square plus 3 by 4 plus cot inverse 2 square plus 3 by 4, cot inverse 3 square plus 3 by 4. So we'll write this series in terms of summation, and we'll write partial sum. So we'll write summation r varies from 1 to n, and it'll be cot inverse r square plus 3 by 4, and that's your general term. So we'll write this general term as tan inverse 1 upon r square plus 3 by 4. Now what we'll do is we'll add 1 and subtract 1. So we can write this as tan inverse 1 upon 1 plus r square minus, now 3 by 4 minus 1 is 1 by 4. So we'll write this as tan inverse 1 upon 1 plus r plus 1 by 2 into r minus 1 by 2. So we can express this as tan inverse r plus 1 by 2 minus r minus 1 by 2 upon 1 plus r plus 1 by 2 into r minus 1 by 2. So its general term will be tan inverse 2r plus 1 by 2 minus tan inverse 2r minus 1 by 2. Now we'll find its partial sum. So we'll write S1. S1 will be tan inverse 3 by 2 minus tan inverse 1 by 2. S2 will be tan inverse 5 by 2 minus tan inverse 3 by 2, and then Sn will be tan inverse 2n plus 1 by 2 minus tan inverse 2n minus 1 by 2. Now here these terms, they'll cancel. We'll get partial sum as tan inverse 2n plus 1 by 2 minus tan inverse 1 by 2. Now we'll take this limit n tends to infinite, Sn, it will be this tan inverse infinite, which is pi by 2. So it will be pi by 2 minus tan inverse 1 by 2, and pi by 2 minus tan inverse x is cot inverse. So it will be cot inverse 1 by 2. So answer to this question is cot inverse 1 by 2, or we can also write it as tan inverse 2. And that's your option B. Now here the question is, we'll need to find sum of this series, which is summation r varies from 1 to n sine inverse under root r minus 1 upon under root r plus 1. So our general term is sine inverse under root r minus under root r minus 1 upon under root r plus 1. Now one of the way of solving this question is to change it in terms of tan. So we'll take this as theta, then sine theta will be under root r minus 1, and here it will be r into r plus 1. We have to find this base. So this base say b, it will be b square equals under root of r into r plus 1 square minus under root of r minus 1 square. So this b square will be r into r plus 1 minus, and here will be r plus r minus 1 minus 2 times under root of r into r minus 1. Now we'll simplify this. We'll get b square as r square plus r minus 2r plus 1 minus 2 into under root of r into r minus 1. Here r and minus 2r will cancel, so we'll get r square minus r plus 1 minus 2 r minus 1. So it will be actually under root of r minus 1 whole square plus 1 minus 2 under root of r into r minus 1. So we can write this b square as 1 plus under root of r into r minus 1 whole square. So this b is actually 1 plus under root of r into r minus 1. So we can express this sine inverse as tan inverse under root of r minus 1 upon 1 plus under root of r into r minus 1, which is nothing but tan inverse x minus y upon 1 plus xy. So we can express it as tan inverse under root r minus tan inverse under root r minus 1. Now we need to find its partial sum Sn. So we'll write T1. T1 will be tan inverse under root 1 minus tan inverse 0. T2 will be tan inverse root 2 minus tan inverse under root 1. T3 will be tan inverse root 3 minus tan inverse root 2, and then Tn will be tan inverse under root n minus tan inverse of under root n minus 1. Now if we'll add them all up, tan inverse 1 will cancel, tan inverse 2 will cancel. We'll get this result Sn as tan inverse of under root n, and that's your option 3. So now the question is, if summation r varies from 0 to n, r square plus r plus 1 into factorial r is equal to 4000 into 4000 factorial, find the value of n. So again what I'll do is, I'll write the general term and I'll say maybe this is t r plus 1th term and this is r square plus r plus 1 into factorial r. Now what I can do is, I can also write it as r square. Now I add one more r to it, so 2r plus 1 minus r into factorial r. So this is a plus b whole square, so I can write it as r plus 1 whole square minus r into factorial r. So I'll write it as r plus 1 whole square into factorial r minus r into factorial r. Now here r plus 1 whole square into factorial r, I can write it as r plus 1 into r plus 1 into factorial r, and this is r into factorial r. Now r plus 1 into factorial r is simply factorial r plus 1. So this is r plus 1 into factorial r plus 1 minus r into factorial r. Now I need to put the value of r starting from 0 and up to n. So if I'll put r as 0, I'll get my first term, and the first term will be, so 1 into factorial 1 minus 0 into factorial 0, which is 1. So second term will be, so if I'll for second term I'll put r as 1, so it will be 2 into factorial 2 minus 1 into factorial 1. Third term, so it will be 3 into factorial 3 minus 2 into factorial 2, and go on, and finally I'll put the value of r as n. So this is Tn plus 1, so it will be factorial n plus 1 into n plus 1 and minus n into factorial n. Now if I'll add all these terms, I'll get the value of this summation. So if I'll add them, so these terms, they'll get cancelled. So what I'm left with is the sum of all these n plus 1 terms will simply be n plus 1 into n plus 1 factorial, and it is given as 4000 into 4000 factorial. So if I'll compare, I can simply write the value of n should be 3999. So answering this question simply is the value of n should be 3999. So let us take up another problem. The problem is, let sk, which is defined as 0 when k is 1, and 1 upon factorial k minus 1 when k is greater than or equal to 2 for every natural number k. Then we have to find the value of 100 square upon factorial 100 plus summation. The value of k varies from 1 to 100 mod of k square minus 3k plus 1 into sk. So what I'll do is, I'll first put the value of sk. So if I'll put the value of k as 1, so I'll get this value as 0. So I'll actually write it as 100 square upon factorial 100 and then plus summation. The value of k varies from 2 to 100 and then I'll write it as mod of k square minus 3k plus 1 and then I'll put the value of sk, and the value of sk is 1 upon factorial k minus 1. So as we all know, these factorials, they are positive numbers, so they'll come outside mod. So I'll get mod of k square minus 3k plus 1. So if I look at k square minus 3k plus 1, so if I'll find roots of this expression, I'll write it as 3 plus minus under root 9 minus 4 divided by 2. So this is 3 plus minus under root 5 by 2. So if I put it on a number line, so this is 3 minus under root 5 by 2 and this is 3 plus under root 5 by 2. Now 3 minus under root 5 by 2, this value root 5 is 2.2 something. So 3 minus 2.2 something is 0.8. So there will be nearly 0.4 something, and 3 plus under root 5, so there will be 5.2 divided by 2. So there will be 2 point something. So nearly 2 point something. So what I know is the sign of the rightmost will be plus and then minus and then will be plus. So in this case, when the value of k is less than 2 point something, so this expression is negative, and when the value of k is greater than 2, then or 2 point something, then this value is positive. So I'll actually express it as 100 square upon factorial 100. Now for the first one, when the value of k is 2, if I'll put the value of k as 2, so I'll get it as 4 minus 6 plus 1 into 1 upon factorial 1 and then plus I'll express it as summation. The value of k varies from 3 to 100, and in that case, now this expression will be positive. So I'll simply write k square minus 3k plus 1 upon factorial k minus 1. So this is 100 square upon factorial 100 plus, now 5 minus 6 is 1, 1 upon factorial 1 is simply 1, and then plus, I'll write it as summation k equals 3 to 100. Now what I'll do is I express it as k square minus 2k plus 1 minus k upon k minus 1 factorial. So I'll write it as 100 square upon factorial 100 plus 1 and summation. The value of k varies from 3 to 100. So this is k minus 1 whole square upon factorial k minus 1 and then minus k upon factorial k minus 1. So I'll write it as 100 square upon factorial 100 plus 1 and plus summation. The value of k varies from 3 to 100, and this is, I can write k minus 1 as, so this k minus 1 will get cancelled and this will be factorial k minus 2 and then minus k into factorial k minus 1. So what I'll do is I'll start putting in the value of k. So if I'll put in the value of k, I'll get it as, so this is 100 square upon factorial 100 plus 1. So now if I put the value of k as 3, I'll get it as 2 upon factorial 1 minus, now here will be 3 upon factorial 2 plus, now if I'll put value of k as 4, so I'll get this as 3 upon factorial 2 minus, now it will be 4 upon factorial 3, and this series will continue and will continue up to 100. So here I'll get 99 upon factorial 98 minus 100 upon factorial 99. Now if I'll add them, so these terms they'll get cancelled. So what I'm left with is 100 square upon factorial 100 plus 1, and this is 2 upon factorial 1 and minus, so there'll be 100 upon factorial 99. So what I'll do is I'll multiply it by 100 and divide by 100. So I can write it as 100 square upon factorial 100 plus 3 and minus 100 square upon factorial 100, which will get cancelled. So answer to this question simply will be 3. Now here the question is, let Vn be a sequence defined by V1 equals 1 and Vn plus 1 equals Vn square plus 1 by 5 to the power n whole root. Then we need to find limit n tends to infinite Vn. Now we can write this expression as Vn plus 1 square minus Vn square, and it will be equal to 1 by 5 to the power n, and will be greater than 0. From here we can write Vn plus 1 will be greater than Vn, that is, this sequence is monotonic increasing sequence. Now we can write V2 square minus V1 square will be 1 by 5, V3 square minus V2 square is 1 upon 5 square, and then Vn square Vn minus 1 square will be 1 upon 5 to the power n minus 1. Now we'll add everything. We can write Vn square minus V1 square, which is 1, and it'll be 1 by 5 plus 1 by 5 square up to 1 upon 5 to the power n minus 1, that is Vn square is 1 plus 1 by 5 up to 1 upon 5 to the power n minus 1. Now this is nothing but a GP whose sum is a into 1 minus r to the power n upon 1 minus r, which is 1 minus 1 by 5. Now we take this limit n tends to infinite. This value will be 0. So this value will be simply 5 by 4. So limit n tends to infinite. Vn square is 5 by 4. Then this limit n tends to infinite Vn will be simply under root 5 by 4, and that's your option B. Now in this question we are given an AP with first term 7 and common difference of 8, and T1, T2, T3 be such that T1 equals 3 and Tn plus 1 minus Tn is An, then which of the following is or are true? Now we are given that Tn plus 1 minus Tn, it is equal to An. Now Tn minus 1, it will be An minus 1, and the same way T2 minus T1, it will be equal to A1. Now if we add them all, then all these terms they'll cancel. So from here we'll get Tn plus 1 minus T1, it will be equal to this series, which is A1 plus A2 up to An, which is nothing but sum of first n terms of this AP. Now this is Tn plus 1 minus T1. Now T1 is simply 3, and sum of n terms of this AP will be n by 2, 2a, and 2a is 2 into 7 plus n minus 1 into common difference of 8. Now this is 2 and this is 4. So this Tn plus 1 will be 3 plus n into 7 plus 4n minus 4. So basically this Tn plus 1, it will be 4n square plus 3n plus 3. Now first we'll find the value of T20 and T30. Now if we put n as 19, we'll get 4 into 19 square plus 3 into 19 plus 3. Now this value is 1504. That means this option A is incorrect. And for T30, we'll put n as 29. So it'll be this 4 into 29 square plus 3 into 29 plus 3. And this value is 3454. That means this option C is correct. Now we have to find this summation. K varies from 1 to 20 and 1 to 30. So we have to simplify this summation. K varies from 1 to, suppose, capital N Tk, which is T1 plus T2 plus Tn. Now we can also write this as this summation. K varies from 0 to n minus 1 T K plus 1, because again will be T1 plus T2 up to Tn. Now this is summation. K varies from 0 to n minus 1, and this is 4k square plus 3k plus 3. So this is 4, and summation k square is n plus 1 to n plus 1 by 6. Here we are dealing with n minus 1, and 3, and n again is n minus 1, n divided by 2, n plus 3, and here this value, it will be n. Now first we'll find this summation. K varies from 1 to 20 Tk. Now here value of n is 20. So if we put n is 20, so it will be this 4 into 19 into 20 into 39 by 6 plus 3 into 19 into 20 divided by 2 plus 3 into 20. And this value is 10510. And summation K varies from 1 to 30 Tk. Now here we'll put n as 30, so it will be this 4 into 29 into 30 into 59 divided by 6, 3, 29 into 30 divided by 2 plus 3 into 30. And this value is 35615. So it is 10510. This is correct, and 35615. That means option D is incorrect. So the correct options are B and C. Now question number 13 is, the integral part of this summation is, now we can write 2 under root n, it is less than under root n plus 1, and it will be greater than under root n plus under root n minus 1. Now we'll take reciprocal, then we can write 1 upon 2 root n, it is greater than 1 upon under root n plus 1 plus under root n, it will be less than 1 upon under root n plus under root n minus 1. Now we'll multiply with its conjugate. We can write under root n plus 1 minus under root n is less than 1 upon 2 root n, and it is less than under root of n minus under root of n minus 1. Now we'll put n is 2, we can write root 3 minus root 2, it will be less than 1 upon 2 root 2, and here will be root 2 minus 1. Now we'll put n as 3, we'll get root 4 minus root 3, and it is less than 1 upon 2 root 3 is less than root 3 minus root 2, and we continue this series up to 9999, then we can write
under root of 10,000 minus under root of 9999, it is less than under root of 9999 minus under root of 9998. Now if we'll add them all, then in that case this root 3, root 4, it will cancel. On the left hand side we'll get under root of 10000 minus root 2 is less than 1 by 2, this summation 1 upon root n, when n varies from 2 to 999, and it is less than, now on the right hand side everything will cancel and it will be under root of 9999 minus 1. Now we'll multiply it with 2. So we'll get 2, and then this square root will be simply 100 minus root 2 is less than this summation, it will be 2 times under root of 9999 minus 1. Now 200 minus 2 root 2 is 197.17 something, and then this summation 1 upon under root n, and it will be less than, and this is 197.99. So this value, it lies between 197.17 to 197.99. So greatest integral function of this summation 1 by square root of n, it will be 197, and that's your option number B.
Now here the question is, we are given this relation which is an equals an minus 1 plus 1 upon an minus 1 for all n greater than 1, and it is given that a1 it is equal to 1. Now it says we need to show that a75 will lie between 12 and 15. Now a1 is 1. If we write a2 is 1 plus 1. So a2 will be 2. a3 will be 2 plus 1 upon 2, which is greater than 2. And since it is an increasing sequence, any an will be greater than 2 for all n greater than 2. Now we look at this given condition. Now it says an equals an minus 1 plus 1 upon an minus 1. Now we square it, we can write an square as an minus 1 square plus 1 upon an minus 1 square plus 2. Now we know that this is always greater than an minus 1 square plus 2, because we are leaving out this positive term 1 upon an minus 1 square, and we know that any an it is greater than 2, then 1 upon an will be less than 1 by 2, or 1 upon an square will be less than 1 by 4. That means it will always be less than 1. So we can write it will be less than an minus 1 square plus 3. So from here we can write an minus 1 square plus 2 will be less than an square, and will be less than an minus 1 square plus 3. Now we can also write this as 2 is less than an square minus an minus 1 square, and will be less than 3. So we have this relationship that difference of squares of any two successive terms of the sequence will lie between 2 and 3. Now we'll start with n as 2. So we can write 2 is less than a2 square minus a1 square, and will be less than 3. And if we put n as 3, we'll write a3 square minus a2 square will be less than 3, and for n equals 4 we'll get a4 square minus a3 square will be less than 3, and we'll continue up to an square minus an minus square will be less than 3. Now if we add them all up here, this a2 square will cancel, a3 square will cancel, so all these terms will cancel. We can write 2 plus 2 plus 2 n minus 1 times. So there will be 2 n minus 1 will be less than an square minus a1 square, and will be less than 3 plus 3 plus 3 n minus 1 times, and there will be 3 n minus 1. Now we are given that value of a1 is 1, so we can write 2 n minus 1 plus 1 will be less than an square and will be less than 3 n minus 1 plus 1. So this is the result that we have from the given condition. Now it says we need to prove that A75 will lie between 12 and 15. So what we'll do is we'll put the value of n as 75. So we'll put n equals 75. So this is 2 and this is 74 plus 1 will be less than A75 square and will be less than 3 into 74 plus 1. Now this is 149. It is less than A75 square and will be less than 223. Now we know that 149 is greater than 144 and 223 is less than 225. We can write 12 square is less than A75 square and be less than 15 square, or A75 will lie between 12 and 15, and that is the answer to this question.